there's just going to be some music for a minute. So just give me one more sec.
When does it show up on the YouTube?
It's about a minute behind, maybe a minute and a half. Should be coming up any minute.
And it'll say like live or something?
Yeah, it's actually already on mine, actually. So,
okay, cool.
All right. And Eric is online, so I'm going to get him in here. And there's Eric. Good evening. Audio is coming. All right. So I'm gonna forego the promo because I can't get it working right. But we are going to go live right now. All right, let me just make sure that. Yep, it's actually on live. We're live on YouTube right now.
Good evening.
Just give me.
Hey, Adam.
Hi, Eric.
Hi, Eric. I'm just setting up 1 second on Facebook, just sending it all the groups, and then we're going to be good to go.
Sounds good, bud.
How you been? All right?
Yeah, pretty good, pretty good. How about yourself?
Good. Everybody, I think everybody's healthy.
Yeah. Adam, it's a real pleasure.
Very, very nice to meet you. I don't know that we've ever met.
No, but I've seen your videos, and you've seen you on the Astro Imaging channel, some of your tutorials, and
right.
Big fan.
Oh, great. Thank you. I'm going to step away. I'll be right back.
Yep. Not a problem. All right, all right. I've been bouncing back and forth, Dan, on the 2600 or the 533 MC.
Oh yeah,
yeah. I think.
What are you gonna do? Did you get the wife to go along?
Yeah, yeah. I think we're gonna go for the 2600.
Oh my goodness! Yeah. I'm scared. Actually,
yeah.
A friend of mine just got his Eagle 3 Pro, and I was just walking him through it.
Okay.
How to get it hooked up to his home network.
Nice.
And,
okay.
Actually, we're live actually, but that's okay. I'm just finishing sharing to some groups, and then we'll be done just after this. I didn't want to do ZWO. Beginner Astro. This thing. And I think that's one more. And there we go. We are all set.
Awesome.
All right. Let's see. Let me just get my Zoom back up here 1 more second. And I think we're all back and we're good to go. And good evening, everybody. Dan Higgins here with Eric and Adam. and Adam Block here.
Yeah.
We're glad to have Adam to come join us and show us some stuff on PixInsight and what he's got going on. And with that being said, Adam, go on right ahead and take it away.
Oh my goodness, that's it? No, you've got to prompt me with questions. You can't just say go.
I thought, yeah, I'm sorry. My bad.
Yeah.
So you do, you obviously got this PixInsight tutorial thing going on
Yeah.
with Atom Block Studios, which I know I've said in previous videos that I've been using it, and I'm actually a person that uses it. And I've been finding some great little things, big things, anything from noise reduction to, you know, basic pre-processing. It's been a really great tool for me to use, especially when you're dealing with something that's high end like PixInsight and a lot of
Right.
tools in there.
Right.
So let's talk about a little bit about your background.
Yeah, that might actually be a really good place to start, because well, in the sense that one of the things that I'd like a chance to maybe explain is that the astrophotography is really only one facet of you know, the things that I'm involved in and the things that I've been doing over the past many years. So the thing that I had been doing for a very long time were the administration of various kinds of public outreach programs, programs that were designed to give access to observatories and telescopes, and if I were to say it in the fancy way, access to the universe. So I helped develop a program that still runs at Kitt Peak. It's the nightly observing program there. I started there back in 1996. And so I worked there for a while developing those programs. But then after almost a decade, I wanted to really build something that I thought was going to be the very best program of its kind. So I ended up going back to the university. I graduated from the University of Arizona. That's where I live here in Tucson.
Nice.
So I went back to the university and I suggested, hey, you know, you can see this wonderful program at Kitt Peak. Would you like your own wonderful program? And so that fell into place, and it became what's now called the Mount Lemmon Sky Center. And those observatories, those telescopes, are on top of Mount Lemmon, which is just to the north of Tucson. So Kitt Peak, the National Observatory, is southwest of Tucson, and Mount Lemmon is just north of Tucson. So these are two big destinations in some sense, not only for astronomers who use the telescopes to do professional, you know, research, but also for public outreach, for the public to be able to participate and really enjoy astronomy in a number of different ways. So in both programs, I would both design presentations and be something like a public speaker, where I would spend many hours at a time with, well, over the course of these couple of decades, I mean, tens of thousands of people. So I've presented to people during these programs and their hour-long presentations for long periods of time. And that takes, you know, some energy. But one of the interesting things about those kinds of programs is that you can only really do that outreach for as far as your voice can carry, because those people right in front of you, that is who you are really speaking to at that moment. But the astrophotography, taking pictures through a telescope, that has much greater reach. And personally, it's something that I've often, you know, really enjoyed, is to have these opportunities to not only see things through a telescope, but some way capture them, in some way, you know, really somehow get my hands on, in the best possible way, the excitement that I feel in terms of astronomy. And showing pictures is a great way to share that excitement. And it's a great way then to extend the reach that I was able to do as far as public outreach. Images, of course, can go around the world.
Yes. And Adam, let me ask you this. For you, you're obviously you have a lot of experience with this, with astrophotography. Myself, I've only been at it for a very short time, a couple of years, as well as a lot of other people just really getting into, because the technology right now is so much more accessible. Yeah. Than it has been in the past. When you first got started, can you recall like maybe your first image, or what really got you, you know, hooked?
Well, so I've let me tell you a little bit about my background. A lot of people who are familiar with me already know this, but my interest in astronomy began at a very early age, maybe 3 or 4 years old. I mean, as soon as I looked up, there was this dimension up there that apparently got me excited. So I've always been into astronomy, but specific to astrophotography, when I was around 12 years old, I got my first kind of real telescope, in the sense that it was a Celestron, one of the C8s. It wasn't an orange model, a black model, but no computerized anything, right? It's just a regular optical
I know
tube
that
on a
one.
mount, right?
Oh yeah.
So, but it was about that time that I was also given a film camera. And so one of the first things I wanted to do with this camera was attach, and I actually have it here. Anyway, I would attach it to the back of the telescope and try to, again, capture images. So my first astrophotography would be with film, you know, when I was 12.
Okay.
But it was in college when I had a chance to really access a large telescope on the campus of the University of Arizona. There's a 20-inch, a very long focal length telescope. It's called the Ray White telescope now. And through that telescope at the time, now this would have been in the early 90s, you know, CCD chips and cameras were only just starting to become available to amateur astronomers. And so there was a set of cameras. In fact, the very first one was an ST4. Do you guys know what that is?
Oh, yeah.
Santa Barbara Instrument Group. ST4 is a tiny chip that's really supposed to be used for guiding.
Yes.
You don't take pictures with it. It has like 256 pixels on a side or something. And so that's what I put at the back of the telescope. Now this telescope, it's a 20-inch, but I believe it is it might be F22. Yeah. It's
Wow.
Yeah.
Wow.
Okay. So the Ring Nebula on an ST4 camera is a big blurry gray ring.
Yeah.
Yeah.
You just see a big donut.
Mhm.
That was my first CCD image, is with an ST4 camera back in the early 90s. Now I continue to use that telescope. There is a professional astronomer who made available some other telescope. It was an ST6, I believe, that we had a chance to play with at the back of the telescope. And of course, I got excited about it. And I think at the end of my time in college, Hyakutake was just starting to come around.
Wow.
And so I had a chance to take some pictures of that through the telescope, and of course up with my own stuff too.
Sure. Wow.
Yeah, so that was my beginnings, but that isn't where it gets interesting. Where it gets interesting is, again, as part of the public outreach I was doing when I was at Kitt Peak, and of course continued at the Mount Lemmon Sky Center, is I always wanted a component of those programs to be astrophotography. And at Kitt Peak, I started with using a 16-inch LX200 to do astrophotography.
Okay.
Now, maybe today that wouldn't seem like such a strange thing to do. But back in 1996 and 97, LX200s were not designed to do astrophotography, anything but.
Right.
There were a lot of things, and I'm not trying to bash, you know, Meade here, but those telescopes just were not made for the tolerances and the you know, the precision that was necessary to do really nice imagery.
I know I had one.
So that's where I started, and so I started in the I really put in my whatever it is that was necessary to start trying to understand the thing of it.
Sure.
That's where I began. It was with an ST7 that was blind as a bat.
Oh, yeah.
Because at the time, you know, these cameras in blue, you could expose for infinity and still barely
get the image. Yeah.
Yeah. And that's only if the telescope was somewhat tracking and all this kind of stuff. So
Sure.
that's where it began. And I began in a different way, in the sense that I was never really on my own, because I always had someone with me. So I was learning on the job with someone looking over my shoulder, which is a little bit of extra pressure, right?
Sure.
Imagine there's someone looking over your shoulder every time you take a picture with your stuff.
Yeah.
Oh, wait, that's not right.
Yeah, right. Right. So, most people were very, very understanding, especially in the beginning. Very understanding. Yeah.
Oh yeah, absolutely. That's a good. That's also could be a very good asset when you got somebody kind of looking over your shoulder, as opposed to not having somebody kind of nudging you in that direction that you kind of need to be in if they're a little bit more knowledgeable than you are. So it's nice to have that somebody.
Yeah, and I think that one of the things that really benefited me in particular, of course, living here in the Southwest, it's clear very often. And because I made that a part of the programs, I would be using the telescope to do astrophotography in a month's time. I could be using the system more than most people might even do in a year. So my learning curve, seeing patterns of things, seeing how the telescope behaved, the camera worked, all of that stuff took place for me in a time scale that is much greater than what other people would have necessarily experienced doing. And that was just because it was part of the job. Sure. But well, that really helped.
Yeah, I'm so sure it did.
Now, just an average question, I guess. So how many days, I guess, in a standard year approximately do you get to actually image in Tucson?
You know, as part of the programs, I would say that we averaged, for imaging purposes, it's more than 200, but I don't think it's 300. It's somewhere between 200 to 300 kind of nights. Now, they're not all the same quality kind of nights, right? You know, some will have clouds, some of the seeing will be poor, sometimes the equipment's not working, you know, all kinds of stuff.
Sure.
But something between 200 to 300 is, you know, 60% of the time or better, you should be able to do some stuff.
Yeah, so when you're down in the Southwest, in that desert area in the Valley, Arizona, New Mexico, those areas,
yeah,
those are, at least in my opinion, those are the peak, you know, United States. Those are the spots. Those are, in my opinion, those are the two states.
Well, that's why you have all these
that, you know, because you have exactly you have all those observatories, and of course, you know, you have Hawaii, you know, and
sure.
everything. But yeah, if you talk about the continent of the United States, it's either New Mexico or it's, you know, or it's Arizona, because you got.
So I'm doing this, you know, I'm doing this astrophotography as part of these programs.
Yes.
But then what becomes a logical extension is that I invite people to come and I do workshops. So I did that, you know, a little bit at Kitt Peak and then did more of that at the Mount Lemmon Sky Center. But then you're limited again by how many people can actually come to you, because I couldn't travel to other people. I had to do the thing here. So that then, of course, became the natural extension of creating content that would be more available through lessons or recorded videos and so on. So I began by making tutorials and saving them on DVD drives, which was terrible because the quality of DVD drives are just a crazy, they're not consistent. And then eventually USBs, and today online. Now I don't need to send anything to anyone, and that is so wonderful. People can access the video tutorials and lessons of what I've learned over these many years online. That's great.
Yeah,
now, that's really awesome. It really is.
So now might be a good segue. I can show one of the web pages that I maintain online to indicate where those lessons are. Would you mind if I share the screen?
Absolutely.
All right. Now I got to be a little careful here. So let's be
actually,
sure.
When you got your first question already.
Oh, what? Well, let me go ahead and address that.
Good.
What's
the first question? Maybe a little bit, you know, a little bit in the advanced part of the lesson, I guess. But when is using local normalization appropriate?
Oh my goodness.
It's a little advanced, but
so I will segue and answer the question by first showing you the web page.
There you go.
Show you the part. I'll show you the section that I have that explains the answer. And then I'll give as much of the answer as I can right now without actually, you know, demonstrating on data.
Sure.
All right.
Absolutely.
So let's do that. So I'm going to go to Zoom. And then if I say share screen, and I will just share the whole screen because I'm daring.
Okay. And there we go.
There we go. So this is as you can see here, it's atomblockstudios.com. And this is one of two sites that I basically maintain. The other site would be the results of these lessons, which would be the pretty pictures. So I have another site that I maintain that's just for pictures. It's atomblockphotos.com.
Nice.
Yeah. And then if you should go there, you can always see whatever the latest image is that I might have made or produced or something like that of interest. And I will get back to, for example, well, this one is interesting. I can talk about that later if you'd like, but the one I really want to show you, I'll just load it up here and then I'll go answer the other thing. The one I want to show you is this one. Okay, so back to the studios. The question was about local normalization.
Right.
I believe, I don't know where I do so many of these lessons that I may have put that one in the more advanced section. At the time, I thought that's where it should go. And yeah, there it is. So I have, going to my site, all of the content is available so people can look and see all of the lessons and see what kind of information I'm providing. And I do have a couple of sections on local normalization. Notice the length of the sections though.
Mhm.
I'm serious about this stuff.
Oh yeah.
Oh, yeah.
These are not 5-minute, here's what button to press. I really do try to explain various features of the process, but I try to do it in the context of astrophotography in general. Many of the concepts, many of the things that we do are applicable no matter which program you're using. And it goes towards kind of the science, if you will, of taking pictures of space, using telescopes and CCD cameras and all of that kind of stuff. I think that all folds together in a comprehensive story. And that's what these lessons try to elucidate.
Okay.
So the answer to the question though is local normalization is a method in PixInsight that when you have a set of images that you want to integrate together, you can, normally when you take a set of images, what you need to do in order to do pixel rejection and other operations is you need to remove variations in either the signal strength or the brightness of the sky, because the sky varies in its brightness as you just take pictures, even if it were perfectly clear. As you look through more air, as you get lower in the sky, all kinds of things are always changing. So there's a pedestal amount that you need to change. That's one part of normalization. And then there's another part, which is you can determine how much signal there is from one picture to another. So if you had like a thin cloud, an image might look dimmer than another image where there wasn't a cloud, or again,
Sure.
looking through more air. So the amount of light that you see is also affected. So the process of normalization determines those numbers, and then you apply that to all the images to do the next kind of step before you integrate everything. But local normalization does it differently. The normalization, you just apply that, whatever those two numbers are I just said, across the whole image globally. Local normalization does that math based on little sections of the image. And so if you have variations in, for example, in non-uniform illumination of the field due to, could be anything, it might be due to some kind of gradient or something that might really be changing, like clouds. That's a very good example. Local normalization will make it better. What you do is you take a set of images that you know are good, combine them together, and that becomes a reference. And then the local normalization process uses that reference to determine what those values are to compensate and adjust your image. Normally, again, you would calculate that, but this time you're using the reference image as the means to calculate it. And if the reference is good, it's going to remove all of the things that are different in all of the other frames. So local normalization is a way to get rid of certain kinds of non-uniform or weird illumination that just might be different from night to night. Could be clouds, other things like that. Usually large scale things, not so much small scale, mostly large scale differences in images.
Like a satellite trail? Or...
Not a satellite trail so much.
Okay.
Really large scale stuff. So I, for example, took some data. Let me show you the picture.
Sure.
I took a picture of Rho Ophiuchus, right?
Okay.
And this is a, let me find it here. This is a 3-panel mosaic, actually. So there are 1, 2, 3 panels here, right? But this is just 2 of the panels in this shot. Wow. However, when I was taking pictures, this stuff is always very low in the sky. And I had to start with the object being very low. And then it got up to some reasonable height from even Arizona. It doesn't really get up that high. It's near Antares, right?
Yeah.
It's higher than like, it's not even 30-something degrees, 38 degrees maybe. I can't do the math in my head, but
yeah, it's pretty low.
Pretty low.
Yeah.
And so you're always going through that air. And so if I were to bring up the data and you blink the data, you would see the, why don't I do it? You can actually see the changes in the data, and you can see why local normalization would be an important thing to do. So maybe in a minute I can bring up the data. It'll probably take it a minute to actually load the thing, you know?
That's okay.
Yeah. Now, let me ask this, Adam. As I said, I'm still sort of new to imaging. And for people like myself who have maybe just purchased PixInsight, and for a lot of us newbies, it can sometimes be a little overwhelming and quite a bit of a learning curve. Now, with your fundamentals, for example, would say for me, would that be something that I could go along with and say on a day 1 of learning PixInsight?
Oh, absolutely.
Would that be something, would fundamentals be something like that? So I can just start off day 1. I just bought PixInsight, and now I just want to start learning.
So the answer is yes, to start learning. Now, starting to learn and creating a picture are 2 different things.
Sure. Oh, absolutely.
Yeah.
Absolutely.
All right. So what I would say is that in the very first sections, and I think Daniel alluded to this in the I just happened to pop on because I'd never seen this thing before on Facebook. And, you know, he alluded to the fact that he learned a few things in the very first lessons. And those first lessons are what I call quick start. So if you look here in fundamentals, there it is. See, I have a section called quick start. And if you just go through this stuff first, and you make sure you understand a little bit about some of the behind the scenes of the interface and about images and making sure we're all talking the same language and so on and so forth. Once you've got this under your belt, then you can go do, you know, the other cool things that are in the rest of the list here. You just go down this list and you will have what I believe to be a coherent way. At least it's ordered in the way that I learned things. And I think it might work well for many people.
Sure.
Yeah, it's organized in some sense. You don't want to, you know, you can jump around, but then sometimes it's hard to make a story out of it, to put it all together, see how they are interlinked. A lot of these things depend on each other, and showing those dependencies is just as important as explaining one thing or another thing independently.
Now, I also think that, you know, as you go through the actual fundamentals, which I'm almost done with them all. There's quite a bit in there. But as you go through them, and I think one of the things that you do good is that you actually start with the background stuff first, and you actually show people what things do before they get into doing them.
Yeah. And I think that, you know, language matters. And one of the things that I try to do in my tutorials is I try to be as consistent as I can with the words that I use to describe something, so that when you hear this thing over and over, you'll be hearing the same concept described, you know, consistently. And then your mind will go, oh, I know what he's talking about. He showed this, that, and the other. So you kind of link back to it, that level of consistency. I mean, this is just, you know, methods of teaching, right?
Right.
I think that can be a very powerful tool to use as an instructor, and hopefully equally powerful for someone that is is watching the information.
Sure.
Yeah.
Now, also with fundamentals, I appreciate your answer, because we all want to learn PixInsight. I mean, PixInsight has been one of the top post-processing pieces of software out there. And it's not cheap.
No.
It's not relatively, for most, it's not a cheap piece of software, but then again, when you're talking about the amount of money we spend on our equipment, it's a pretty inexpensive piece.
I hear you, but I don't, this is my opinion, of all the things to spend the money on, there's software, is the thing that allows you the flexibility to take advantage of your equipment effectively. Because I mean, once you have the data, there's two parts of astrophotography. There's the acquisition of the data, which is fine. Assuming you get good data, then you got to do something with it.
Right.
And what you want to do, ultimately depends on what you want to do with the images. For me, I want to try to display as much of that information as I can, because I work so hard to get it.
Sure.
And of course, in some level, I also enjoy, because I do public outreach, trying to tell a story, try to communicate something, be it compelling, inspirational, might be a teaching thing, some kind of scientific thing that's evident in the imagery. Something for me is always the hook, and I try to find those hooks in the images that I take. So let me just show you. This is what these are like what the work in progress of this kind of field looks like. This is just one of these parts. It's not the whole thing, right?
Right.
And so if we go to, hopefully I have enough memory here to do this. If I go to Blink, I should be able to navigate to that directory and just look at the data before I did anything remarkable with it. I didn't need to open the project to do that. I should have been, it's hard to be really thoughtful when you're live, right? So let's see, I've got data here. Let's see, that would probably be under what, calibrated? Light, sure, cosmetized, yeah, registered, okay. And let's look at, like, I don't know, the red data. So we do star, red, star. So there's a bunch of red files, although look what I have here. Do you see how, I don't know if this comes across on the screen. Do you see how it has XNML?
Yep.
Yes.
Those are local normalization files. I'm not lying to you. I actually use the process on this data, which is, it's nice that I don't actually lie about this stuff. .xi, but I just want to open up some of the images so that you can see, as I blink through them, hopefully differences in them. So I'm going to choose from different nights here, maybe, because I don't know from night to night. This has to be random. I took a lot of pictures. These are all like 8-minute exposures.
Okay.
Wow.
All right, whatever. I got a bunch of them, right?
Sure.
It says it's loading the data.
And just out of curiosity, what's your setup as far as your telescope?
Well,
and,
so right now I have,
using?
so right now I have access to an astrograph. It's the Takahashi Epsilon 180.
Wow.
And it's on top of Mount Lemmon.
Okay.
Right. And it is, it's normally used to do a particular kind of research, which I'm happy to show some examples of what that is later. But the principal investigator, the astronomer who's funding, he purchased everything, he was very kind to me. If the telescope is not being used to do this research, then I can sneak in some exposure times for other cool things.
Nice.
Because he allowed me to put broadband RGB filters in the filter wheel in addition to all the scientific filters. And so that's how I'm able to generate some of these images.
Cool.
Wow, that's awesome.
All right, so let me press this button, which will, equalize the screen stretch. And then hopefully, if I blink the images, you will probably see, do you see how the brightness is changing?
Yeah.
Now look at that. What's that? What's on the right side there?
I don't know.
I don't know. And then like on another frame, it was on the left. Now there's some glow up here in the corner. Now, one thing about wide field imagery, I mean, this is 4-degree fields of view, right? So as this thing goes across the sky and it's low in the sky in one part of the sky and then high in the sky in the other, the signal is changing, the gradient is changing, everything is changing. So I used local normalization. I picked a handful, maybe 10, I don't know, of the best frames where there wasn't this kind of variation very much. It was probably when it was highest in the sky.
Okay.
Made that a reference, and then clicked local normalization, made the local normalization files. There's a process to do this. And then when you do the image integration, it does this thing and evens out all of that stuff that I'm showing when I blink the files.
Wow.
Wow.
Okay.
All right.
That's amazing.
I'm going to close all that because that's a large. Oh God, no, don't just.
No, please.
What I want to do is load an empty project. That would probably work for the time being. Okay.
Sure.
Cool. So there's local normalization. Now, one thing that I did mention though is that one of the inspirations for me is to be able to show images that tell a story. And I think an image like this tells a story. One of the stories is that, well, maybe let me pause and ask. This is an object called, it's a spiral galaxy, NGC 2835.
Okay.
Eric, have you seen NGC 2835 before?
I've seen something similar, but I'm going to say no.
I'm
going to say no.
I have not.
I'm going to say no.
I'm going to say no too, because if you look like in Google or something, you look online, you will not find very many high resolution pictures of this galaxy anywhere. And so this is just one of the simple stories, but the story very well could be that, you know, you just like to take a picture of something where there just doesn't exist many good exemplars. So for me, it's kind of like the taxonomy of the universe where you're just collecting things, right? It's the collector of things.
Yeah.
So because I don't know what I'm gonna get. I don't have anything to compare to when I'm processing. There's no comparative thing, and so that means that as I make these decisions in processing, you know, they really are coming from me. I'm not being influenced by anyone or anything else. These are just the way that I would take that data and try to express what I can from it. Yeah.
And these are absolutely incredible. And I've heard that you yourself have been awarded with dozens of APODs. Is that true?
It's multiples of dozens, yes.
Okay, and see, and that makes you're the right person to talk to about a lot of this stuff.
Well, you know, so I've been doing this a long time, and that's really the thing for me, is that it's the length of time I've been doing this, right? Mm-hmm. So when I started again back at Kit Peak, you know, this was in the 96, 97 or so. And so from that point till today, how many years is that? Is that 23?
Yeah,
something like that.
Close to that, yeah,
So
20 years, that's for sure.
20 plus, yeah.
Yeah, 20 plus. So, I mean, I've been doing this thing for that long and without a break. I mean, this is what I've been doing the whole time.
Yeah, it's definitely like, it's interesting because, you know, coming from Long Island, we don't get even close to 200 days a year imaging. Yeah. I mean, literally, you sit there and you go, actually, I'm imaging right now as we speak. But you know, they're very, very rare and few, and you got to grab the hours. It's not even a night, the hours as you could get it. Right. And it's unfortunate with all the changes. And I know Tim is also, and also Eric has the same issue where the hourly change of the weather, it's so unstable.
Yes.
It's like, oh yeah, it's going to be clear tonight. And, you know, you set up, you get everything going, and next thing you know, it's a mess and clouds roll in and your night's over. It really curtails a lot of people to acquiring the data, and takes a lot longer to get the hours needed to get a decent photo without the noise.
Sure. So one of the things that, you know, I don't actually own my own imaging system, right?
Okay.
I've been working in the field, but by working in the field of astronomy, the math isn't really in your favor to buy any of the equipment that's used in the field of astronomy. So,
Yeah.
Right.
hey, I'm still happy because I'm getting to use the equipment.
You're getting used to
Yeah,
you're getting
absolutely.
you're getting used some great equipment.
So I have had that chance, but one of the things that I've been doing recently to supplement the opportunity is I've gotten some time on some from the remote telescopes. So you'll see in my tutorials, for example, that in my I'll explain what these two things are in a moment, but in one section here, I have these example images, and they're from, in this case, it's from Telescope Live.
Okay.
So this data is from telescopes in Chile, and that's really cool for me because these are objects I just can't see from here, and that really gets me excited.
Yeah.
By making this available, that becomes not only a lesson on that data set, but the people that participate here, you get to actually download the data and follow along with me.
Nice.
So all of that data becomes available to people to work with, as well as these are the raw recordings of me actually going through the process and doing what you see. It is, if you are still, in that virtual sense, I always still virtually have someone looking over my shoulder when I make these recordings, and that's exactly the same thing, right?
Yeah.
So it's as if you were there with me, and you can hear me mumbling and trying to decide what the heck I'm doing. One of the things that people really like about my particular style is I tend not to re-record, which means you see a lot of the mistakes. And then I don't know, people tell me it makes them feel better to see me make all kinds of mistakes. So fine, whatever. Yeah. So that's what this is. That's what this is about. So I have these two sections. One is called the fundamentals, which really goes into all the detail about everything I think you really need to know. And that's a lot about PixInsight. And then beyond that, PixInsight Horizons is then the more complicated stuff. It's the stuff that you can't do in just a serialized set of steps, but instead now we're really being creative, and we're only doing it for particular data sets. In a particular case, you do some kind of processing. There might be some particular issue that you have. So I have a section that explains that. That doesn't belong in fundamentals. In fundamentals, you want the typical things that you're going to be normally doing. In Horizons, I give examples of the processing of data sets, how to solve particular problems. And this is the area that I'm always adding to. So this is an ever increasing library of information.
Now, let me ask this: when you with Horizons,
yeah,
are they and with fundamentals, are these two separate blocks? So, or is it so? For example, if I purchase Horizons, or fundamentals, will that and then I will purchase that, but then I'd get for the additional cost, and I can go ahead and later get Horizons.
Yes.
Okay.
Yeah. So the way it works, the way that I've designed this is that fundamentals is it is a collection. It's a library material, although I'm still adding to it occasionally because I want to fill it out. There are some holes that I think I still need to fill. But it's a collection of everything that I think, you just need to know. And that's a lot in PixInsight.
Okay.
But that, once you purchase that, you have forever access. So there's you just are a member. You can always access it. I also have means that you can download the videos to your computer. So if there's problems streaming it, then you can just play them back on your machine. Horizons is something that, because I am always adding to it, it's just ever growing. I did make it to have kind of an initial payment that you get in. And then if you want to continue to stay in and see more material as it comes around, then at the end of a year's worth of time, I ask for an additional subscription. It's not as much as what you originally pay, but it's like an ongoing subscription. Though I have to say, I have yet to charge it, because the very first year I started this, I didn't do it because I wanted to fill up more content. This year, I'm not going to do it either, I think, because of the, the nature of the world right now. It just doesn't make sense to bang people over the head for
Sure.
you know, an ongoing subscription. I'm just going to go ahead and say, if you're in right now, hey, I thank you. And people that want to come in, you know, they can still buy it, but I don't think I need to charge at this point in time for that. So I'll just say, yeah, if you're a member, enjoy. I'll continue to add material here, and I hope that people like it.
Okay. Now, as far as your fundamentals, as far as you say you add on it every once in a while.
Yeah, like if
like
there's
for myself,
new things that come up, you know.
Yeah, because I like for myself and for a lot of us that are new, a lot of us use one-shot color,
right,
to get started.
Right.
Now, I did notice that you have a couple of videos under fundamentals for that, for DSLR, okay, and for OSC.
Right. So
would
what I
you
have
consider
is
adding on to that sometime?
Well, let me give you some background. This is my opinion. One of the things about one-shot color camera is that beyond the issues of calibrating the data initially, which has some vagaries, it deals with the fact that CMOS chips don't work like, you know, there are differences with the Bayer matrix and the gain and all kinds of stuff. So there's that part of it. And then there's the debayering part. But once you've got debayered information and you're all calibrated, there is no difference. Everything else from that point is the same steps that I'm showing throughout, whether it is, you know, RGB plus illuminance or just straight RGB or whatever it is. There's no difference at that point.
Okay.
So I would say that what I don't have here is a complete set of all the solutions to that people have in terms of problems with their CMOS cameras. I don't have that, and that's because I haven't been using CMOS cameras, and I don't have a ton of CMOS data. Nor do I really want it. I'm happy.
The walking noise.
Yeah, I know. Yeah.
That's you know, I have a CCD as well. I have an S big. And I love it. I'll never go back. You know, everyone's trying to push me into the CMOS era, and I'm like, "What's gain? What is gain? What is offset? What are you talking about? I have no idea what you're talking about."
Well, but, it exists in the regular CCD camera.
It does, but
you don't have to worry about certain elements of it. There's a consistency that you don't have sometimes with the CMOS, depending upon.
Right. Yeah. Because I guess with CCD, you know, the gain is set or whatever it is. You don't.
Yeah,
it's
an auto set.
It's an auto set, and that's it. It never changes.
Shouldn't change. And then, of course, when you have a cooled camera, that's another level of maintaining a particular control or consistency, which you may not have with some of the CMOS chips that some people are using. That might be air cooled and whatever. Yeah.
You do have a question from Dan on Facebook. What is the got-to-have astronomy processing software?
All right, so let me give you the politically correct answer.
I was scared about the answer for that.
Yeah. So this is the way I would say it. Now, you're talking to someone who, if you come over on my website and you look down the list here, you'll notice that it is not just PixInsight. So because it didn't exist when, of course, I started. So I have gone through many different eras and epochs of different software programs. So I began, you know, with, well, there used to be a program no one would even know now, but I began with various programs, and then everyone knows MaximDL. It used to be that people would program, you know, would process their images in only MaximDL. That was it, right? And then it would be MaximDL in Photoshop. Then what came about in my mind as a big thing was CCD Stack. That was in its time very big, and it still is a wonderful, very streamlined and concise and tight little program to do what it does. It's great. So CCD Stack is an excellent initial processing program, but you need to couple it with Photoshop to do the post-processing. And then, of course, nowadays, you know, PixInsight. But PixInsight for me was something that took time, because unlike these other things, PixInsight just did not have the kind of, you know, documentation, nor did it have experts who were very good teachers teaching how to use the program. the authors weren't really teaching how to use the program. They were making a great program, but they weren't teaching how to use it. So I felt obviously that there was a need for that. But in order to take advantage of that need, I had to become proficient in the program, and at a level that was high enough that I felt that I could then offer something to people to learn from. And that took me a solid 4 years.
Wow.
Yeah, that wasn't just to make pictures, but this is enough to actually, I think, to teach or demonstrate. Do it in a way
to understand and transfer everything to other people. Sometimes it's people learn at different rates and reasons. So
yeah, and it is powerful if once you know something at a certain level, you can explain it in different ways, for example, and you can explain the consequences of doing one thing over another, and that just takes time and experience and, again, pattern recognition, all that stuff. So that's what took me time to be able to do. But that's why today, if I were going to answer the question, I haven't forgotten the question. I think the answer is PixInsight, mostly because many of the tools that are in the program are super powerful, and there aren't analogs for them in other programs in the same way. At least not that I am aware of. There are some really powerful tools that, that I'm unaware of any particular analogs. People often say DBE, which is the background neutralization, which is an obvious thing to point at, is very powerful. But you know what? HDRMT is the coolest algorithm in the world, because I grew up on, if you will, DDP, if you remember what that is, digital development. And this was in MaxNDL at the time, and then it transferred to a slightly better variation in CCD Stack. But then this different kind of algorithm, which is based on wavelets and so on, so you get different spatial structure sizes and things. That is really cool. And as far as I know, that isn't really well represented in any other software. And there are many examples like that. And so as a toolbox, I do like PixInsight. It's a lot of fun.
Jane on Facebook is saying, would you not agree that a combination of a number of post-processing software is best, as each has their own strong points and ease of use depending on the particular task?
I agree with that in a general sense. One of the things that I have found in using PixInsight is that I haven't had to, now I'm not a purist, I have no, I don't need to live in the PixInsight universe. It is somewhat important for me as I am teaching the stuff to do my best to kind of stay within those boundaries. But no, I'm not a purist. So if I need to use another program to do something, I would, and I always have.
Right.
So if there is a better tool for doing something, I'm going to go use it. PixInsight for me, I found to be very powerful in so many different ways that I haven't found the need to really travel too far beyond. And it does have a very large set of tools. And I think that's really what it is that I think sometimes people, they might find another tool easier to use because they are accustomed to it, or they just may not understand what the analog is in another program. So they end up using a whole set of programs where they know these things very comfortably in each of the programs. But sometimes, it could be that one or the other program also does the same thing, but in a different way, or, you might need to handle it differently or whatever it is. So sometimes people use different programs because it's easier in the sense of being accustomed to doing things in a certain way.
Sure.
Yeah, absolutely.
I mean, I'm not saying that, there are certain tools that certain programs have, and that's the argument I'm making here, that others just don't have. So if you need to go to use that tool, then, that's it. That's what you got to do.
Yeah, I know there is a bunch of plugins. We all know there's a bunch of plugins for Photoshop that have come out over the course of the past 15 years, with that astronomy tools on Photoshop. You got Hasta La Vista Green, you got Astro Flat Plug, you got a whole bunch of stuff that's plugged in. Now PixInsight does a lot of that stuff very well as well.
Yeah, well, but if you look at I guess I'm just having I'm sorry, I'm sharing the screen. You could be looking at me, I guess, but
No, that's okay.
you know, if you look at PixInsight and you go under something like scripts here, you can get these scripts. I'm looking for blend. Does anyone see blend? Yeah. You can get these scripts that have the math. Now, so these are the functions that are in Photoshop, right? And the thing that I hope people take away from this is that it's just a formula. It's just math. It's not as if that is a proprietary mathematical equation. Any program can do it if they implement that particular equation on the pixel.
Okay.
So, you know, as it is expressed here, I could have made this expression in pixel math if I could remember it. Or, you know, it's put together here in this nice script for me that I can take advantage of in PixInsight. So there are, you know, some of these blending modes here that, you know, like overlay or soft light or whatever, that I might want to take advantage of because I'm accustomed to them. But I can do them right here. I don't need to save my image, bring it to Photoshop. It's the same math. I get the same answer.
Now, one of the really cool things that I was just recently watching your demo on the Afro Imaging channel was how to deal with the dust and the dust circles. And you were using pixel math to basically zero out those pixels, and then you did an overlay. I thought that was, you know, there's so many cool things that you can do with this software, and that I've just seen, you know, just I've seen some of your videos that's just so awesome.
So that particular example that you bring up is interesting because I consider it a pseudo innovation. That was something that I kind of figured out because certain tools in PixInsight became available. And so let me just show you the section here that I think I have it in several places.
Yeah.
I would have called it techniques, I guess. There's something called selective rejection. And the idea is that if you have something in your data, let's say you have 10 frames, hopefully you have more. Maybe you have 15 exposures or 20, right? Even better. The more, better. But if you have some problem that's only in some small subset of those frames, if you have the same problem in every frame, this technique doesn't work. You have to use something else. But if you have some subset of frames where there's a problem, then what you can do is what you described, and I would have to log in here to, let's see, can I do that? It's hard. I can't get behind my thing. There we go. That's my administrator panel. Don't do that.
Don't worry, we're not recording. It's okay.
Okay. So that was under techniques. Yeah.
Yeah.
By the way, I'm looking this way because this is I don't know if anyone knows this, that my computer is over here. My camera's there. Anyway, selective rejection. And I bet you if I play but mute, so you don't have to hear me, you only need to hear one of me. There. Yeah, we can
there you go.
skip that stuff. There. Oh, this is okay. This is the example that I went extreme.
Yeah, I remember this.
So in what I did was in the image, I inserted little, can I say it on air here? Poop emojis.
Little poop, yeah, you're fine.
Yeah, little poop emojis. So to represent, it could be anything. It could be the dust donuts, like you said, Eric. It could just be any goofy thing that might be in the image. And it might be in a whole bunch of images. So I put these things in a number of images. And then what I do is the following. Let me just see if I can go forward here. Yeah, let me play. I need to wait for the screen to refresh here. There. And let me stop. Do you see how I've made them black?
Yep.
Okay, so what I did is I made an image here that just has black pixels, and I used the clone tool, but I'm not cloning information, not in the sense that I'm not copying any information here. All I'm doing is assigning those pixels to be the value of 0. And the power of doing that is when I get over here to integration, I'm assuming I'll get there. This might be hard to do. Oh yeah, I'm still inserting things or whatever. Hold on. Let's see. This is hard to do in a video, right?
Yeah, no, yeah. You're trying to link what you're thinking to what you already recorded.
Well, yeah, but it takes a second for it to refresh, I guess.
Yep.
Hang on, let's see if it refreshes here. There it is.
There you go.
Oh, here I go. Let's click the button, Adam. See, I'm talking. Click the button. Let's see. Oh, I already did it. Okay, hold on. I see, I already did it. This is live. I know this is live, but let me just try to go back here if I can. Oh yeah, I need to go back one more thing. What I want to show you is where I say reject 0. That's what I'm trying to do. I might not be able to find just the perfect spot that I'm doing that. There, okay, there it is. Do you see here where I have clip low range?
Yep.
You see that? And then in the next, if I ever open that thing, I must have opened it for just a moment, but there's a button where the low range you specify to be the value of 0. I already skipped it. Anyway,
that's all right.
Specify to be the value of 0. Then what happens is during the rejection phase of image integration, it will say any zeros will not be used. Anything that's colored 0 won't be used. And so if I have, I don't know how many frames here, it looks like 15. If I have 15 frames and I painted black in 4 of the frames, everywhere where there's black will only have 11 values averaged together. Normally, if there was no black, you would have been averaging 15 values.
Right.
But in those areas where I'm rejecting, I'm only averaging 11. So that's how rejection works. But this technique would not have worked except for one more thing. You'll see here that this has large scale rejection. The funny thing is that when you paint those black bits,
right.
PixInsight does not actually do it because it has to interpolate. It doesn't do it on a per pixel basis when it paints.
Gotcha.
It doesn't actually paint 100% black at each pixel. And so this rejection thing that I just described does not work until you do this large scale rejection. What it does is everywhere I painted black, it expands it just a little bit. And that makes any of the boundaries where I might have the edge of that painting disappears.
So kind of feathers it out.
So it makes it a perfect rejection.
Yeah.
That's how the technique works.
I think Eric muted himself by accident.
Well, maybe that helped me. I don't know.
Yeah.
There you go.
There you go.
There you go.
Now let me ask this also. You've been in the profession for so long. Can I ask, what is, if you could choose, like, say, your favorite type of a target, be it nebula, galaxy, dark nebula emission, what would you say would be some of your favorite targets to go after?
All right. So, I mean, the easy answer is something that I haven't done before. I mean, I'm always up to something new, right? But let me show you an example of something that for me was super rewarding. Let's see. And I can demonstrate why. I don't think I have the high resolution picture on this page, but I'm pretty sure I put it on here. I only started this. I have another page that has even older pictures, right? That's what happens when you do this for a while. This one. So,
oh, wow.
This is a cool nebula. So Taurus, the Taurus molecular cloud over there near Aldebaran, between Aldebaran and the Pleiades and all that stuff, there is all kinds of crazy things in there. And this is one of them.
That's wild.
This is SH239, right? Now, here's what I want to show you. You can bring up, and if you guys are not aware of this tool, it's a very powerful tool. You can get the client, you can download it and install it on your computer. It's called the Aladdin Sky Atlas, right? And what you do is you just type the name of the object. So this should be SH239. Oh, I didn't quite get that. try that again. SH2 239. Let's see if I've got the right one. I do. So this is what it looks like, this object in the digitized sky survey image.
Okay.
Wow.
Now, if you looked at this image, right, and you would think to yourself, is that the kind of thing I'm going to spend the next 40 hours on? No, whatever. Some amount of odd, insane number of hours on, right?
Mm-hmm.
Now, remember, this is an object where at the time, there did not exist a comparable image. There was no color picture. I didn't know what I was going to get. I didn't know I was going to get the picture I showed you. Not at all. Now, there were some other kind of professional images, but they're never very good. They don't do the whole object. They're not color images, and it's a mess. So I thought it had something. I could just barely see. There's something here. I could see the outline of a cloud. I knew that if I just spent a lot of time, it could probably reveal something there. And sure enough, right? I spent that time, and that's what you see.
And this is what you're talking
really
about,
cool, right?
And this is what you're talking about when you want to tell a story.
Yeah,
this is a perfect example.
Yeah, and you can see these are all Herbig Harrow objects and jets, and there's this object right here. Again, I need to show you the full resolution image, but there's a thing right here that's super well known by astronomers hidden in here, and you can almost see like a jet coming out the back. So there's an outflow going in either direction here. See how there's a little comma right there in the cloud?
Yeah.
That's because these outflows have punched through the dust, right?
Wow.
That's an amazing picture.
That is absolutely incredible.
Now this is actually the image that was chosen to be the what was it called? The Royal Observatory Astrophotography Picture of the Year, whatever it was, right?
Wow.
This was the one.
I can say, hey, well deserved. I can say that. That's incredible.
I submitted that one. Now let me just show you one more of these. Well, let me show you a couple. Let me give you a tour of the Taurus molecular cloud. It is the weirdest cloud in the world. Look at this thing. What the heck is that? Right? This is another one of these embedded. These are T Tauri stars, really very young stars, very energetic stars. They have lots of maybe outflows coming from them, lots of energy. And so they tend to both illuminate and maybe dissolve the regions around them. And this is a really good example of that. It's very delicate, but I always thought that was a good one. And the most recent one is this one. It's another one of these things in these clouds. And, I just think they are the coolest things in the world. Here's another one of these outflows here, probably related to, one of these stars, this star here, probably. This is CW Tauri here, which is a T Tauri star.
Nice. Got some more comments on Facebook here.
Sure.
How good is PixInsight for getting rid of noise without losing the detail?
That's a really good question. Dealing with noise is something that, programs usually have multiple methods of dealing with. And PixInsight has no fewer than 6, I guess. One of my favorite, though, is one that's called Mur de Noise.
Okay.
Once I discovered that one, wow, I was really impressed. So let me just show you an example here. Let's see. Here. Let's see if I do. Well, I think that's probably good enough. I don't need to enlarge it. Can you see the difference between the left and the right?
Oh, yeah.
Okay. So I found that this particular algorithm is just so fantastic, especially when I have really noisy color data. This algorithm, what it does is it's used when the data is linear right after you integrate a whole bunch of files. So you integrate all of your red files, right? It's still in its gray, black and white state. But then you apply this Mur de Noise to it. And you do the same in the green images and the blue images. And the cool thing about it is that it is not a kernel filter, like where you would look at neighboring pixel values because that tends to smear, that tends to interpolate between values. This isn't an interpolation method. This is actually like a despeckle operation, where you try to model the noise, the expected noise of the image, and then you try to remove it based on that model. And so it despeckles the image in this wonderful way that results in the image on the right. And that's not a final image, but it's just the RGB combined that you can get after you've applied, you know, this mirror denoise. So that is one of a half a dozen. There's TGV denoise. You can use MLT, multilinear transform, and only operate on the very small scales. There's some other operations you can do, but ACN, DCNR, whatever the right? So there's all these different methods. So yes, the answer is yes. PixInsight is great because it offers so many different methods, and especially offers them. They are available in different regimes, different times. So when you're working with the data in its linear state, you can do many of these operations. And then you can also do it when things are nonlinear. You know, it used to be in the past, if you're going to do things like in Photoshop, you already have to be in a nonlinear, you know, stretched image. And then you're just dealing with the noise at that point. But in PixInsight, you have more opportunity and you have more flexibility as to when and where you apply noise reduction. And I think it's not so much of when and where, but the amount. Because you have these different opportunities, you can do very small amounts in different spots rather than have to attack it once, you know, at some point in processing. And that's also very powerful. Iterative processing is always a really good way to proceed when working with astronomical data.
Adam from Facebook says, have you ever calculated the amount of data? Have you ever calculated the amount of data where you don't see any benefits of getting good returns of your data, like diminishing returns? So I guess he's saying how much is enough? I guess that's what he's saying.
Okay, so there is an answer to that question that deals with just strictly signal noise, right? You can acquire enough frames under whatever the darkness of your sky is and so on, that mathematically the amount of more frames that you would need to take to get a big improvement, you know, it doesn't make sense mathematically to spend that amount of time to do it. So whatever those numbers are, I mean, I'm not going to say that that's not true. It's the truth, but you never get there. And you don't get there usually because the data is never that good. At least what I found is that there's always some problem. You know, the problem could be that the images aren't focused, the seeing is poor, the atmosphere changes because you're looking between something at low, you know, high air mass, low in the sky, or you're looking up and there's differences. And what you get to do by taking more frames is throw out the ones that are very poor and then work with the very best that you have. So the game here isn't how many exposures I can get to reach that point of no return. Usually the game is, let's collect the greatest number of high quality images that I can. And usually you're not getting to the point of reaching the signal to noise problem. At least I haven't found that to be the case.
Yeah, I know that there's a program out there called Sky Tools 4 that's out there that actually has got a calculator that you can actually put in the signal to noise that you want, and then we'll calculate based on your rig how much you need to get to that point. And
but based on your rig, that's only if your rig does everything that it should.
Correct.
Correct. And the Sky allows everything that you wanted to, and all these other things that fold into it. So I agree with the calculator, but what I'm saying is it's hard to argue in having more is never enough. You know, it is much better to have too much than too little.
Absolutely.
Yeah.
Absolutely.
And as a maxim of processing in general, the more information you have, which literally means more exposure time or integration or more frames, the more flexibility you have in processing. Oftentimes people, they take relatively shallow or small amounts of data, and they want to apply this whole toolbox in PixInsight. You just can't. The data's not there. You're not going to be able to do, all of these things, all these cool tools, because it requires the signal to be there in the first place. If the signal's not there, you just can't do all of these remarkable, deconvolution and other things. You just can't do it.
Yeah, I see a lot of people when they have little data, they just smash the picture up, and it's just like either over sharpened or over noised it, and then the stars get shrunk.
Well, one of some of the things, especially that I sometimes have trouble with, is knowing how much time I should put into each frame or each light. Okay, is it something based off of your if you're using something with a short focal length versus long, dealing with your f-stops, is it something where, okay, I should be, since maybe I'm using my SCT or I'm using my f7 refractor or something like that, should I be putting in 5 minutes or 7 minutes or something like that, versus if I'm using my 51 millimeter that's at an f4, even my raw set at an f2, okay, yeah, should I be putting in 30 seconds or a minute? So it's always kind of hard to figure those, to try to find that sweet spot sometimes.
I agree, but I would just view the telescope and the camera, everything that you would bundle together as the optics, all right? You just put it all in a box all together. And all I would say is, how dark is the sky when you take your picture, right? So if you're taking a picture with a small telescope and a narrowband filter, the answer is going to be different than if you're taking the same data with a broadband RGB.
Right.
Or it's a different answer if you have a big telescope or a small telescope. But all of these answers tend to be a function of how dark the sky is and then how noisy your camera is. Those two things together interplay to kind of give you, I think, roughly the answer to how long you need to go. So if you have low noise and the sky is dark, and what I mean by, I don't mean the sky that you see with your eyes. I mean that what you observe through the telescope in your data, because it depends on the filter you're looking through, right?
Sure.
So if the sky is relatively dark, if it has low counts, you want to expose as long as you can until you start to really get significant counts of the sky. You don't want the sky to eat up all of your dynamic range. So if you take a picture and you have a 16-bit camera and your sky, suddenly becomes 10,000 counts or 20,000, I mean, that's too much, right?
Yeah.
But you want to get to the point, your exposure should get to the point where your sky is relatively bright. And then again, assuming that the noise of your camera is not an issue, that probably should be roughly right?
Yeah.
I mean, so I would go as long as I can, as long as the sky remains dark, and the noise of the camera itself isn't imposing on the number of frames that I'm able to capture and all that kind of stuff. Yeah, because there's the length of the exposure, and then there's also the number of frames. Just forget for a moment about the exposure time. There's also just the math. You want to get at least, regardless of the exposure, you want to get at least 10 to 15 frames of anything you do, because 10 to 15 measurements, if you will, allows you to do all of the integration and rejection stuff to get rid of satellites and cosmic rays and things that might be varying in your data. So that's almost independent of the exposures that you're using. You just want to have the statistics there to be able to put the images together.
Right.
Yeah.
Totally. I understand. Yeah. Thank you.
Let's see. Jane wants to know if you have an example of a high resolution moon picture.
I do.
I know you do.
But I got to say, when you say high resolution, if what you mean is like, I can't think of who the guy used to be, Higgins, I don't remember. If you mean like through the small planetary type cameras where you're doing the fast frame stuff, actually I don't, but I do have, through big telescopes, pictures of the moon. Let's see, I might have put it on here, and if I didn't, I know where it is. One second. let's see, yeah, but that's not the, okay. So now we're going off script. 1 second.
Sorry.
That's okay. I have yet another website.
Jackson?
Yeah, Jackson, what are you doing? Who is Jackson?
Jackson is Eric's kid, I believe.
Ah.
Yep, that's my 10-year-old, my budding astronomer. Just trying to get him into the hobby.
So this is what
Wow.
a moon picture looks like. I can't remember it. I'd have to look. If I take a step back, I can see what telescope I use. Likely this is the 20-inch telescope. That's what you get without using a webcam. This is just like single exposure mosaic thing of the moon, but it's relatively high resolution, right?
No, yeah, it looks good to me.
Yeah, that looks great to me.
So I used the 24-inch.
Okay.
Back in 2009. And I used the hydrogen alpha filter so it wouldn't blow out the thing. Yeah, but it's just grayscale. It's not. I wasn't trying to do the color thing. That's a whole nother way to do that. And as you can see, I did it with people. Rarely alone, always with
Yeah. Oh, yeah, someone always behind you.
There they are. Looking over my shoulder.
Yeah.
Yeah.
David on Facebook wants to know your preferred method of adding H alpha to LRGB for galaxies.
Oh, for galaxy. So that's
For galaxies.
interesting.
Yeah, that's
So let me just talk about the galaxy thing, and then I'll answer the question. You know, what's interesting about H alpha in galaxies is that only the very nearest galaxies tend to benefit from H alpha in addition. So for example, and the reason is because galaxies, when they're farther from us, they're redshifted enough that H alpha emission no longer is going through the filter. It's shifted outside of the band width of the filter. And so you don't get the big benefit of doing it because they're no longer the same color, literally. I think I have here, I probably don't have the high resolution version of it, but yeah, I just have the low res version. I can show you the high res if you want, but this is H alpha added to the M82, the
Cigar Galaxy.
yeah, right.
Okay.
Yep.
And so this galaxy is close enough to us that the H alpha really does help, and it's really, actually, it is worth me showing. My method, though, is the following while I go get it. It is to put H alpha in both the red channel and, if I have a luminance channel, or I'll make a luminance channel, the luminance channel itself. And I determine how much weight, how much I put in there. So for example, in PixInsight, I might do a linear fit between my H alpha and my luminance, and then I'm going to blend them together at a certain weight. It doesn't need to be 1-to-1. Okay. I could do any amount that I want, but whatever amount I do the same thing in the red channel, so that when I make the color image, it colors everything that I had put in to the same degree in the luminance. Now,
Gotcha.
It turns out you don't need to do a whole bunch. Usually, only a very small amount is enough to really enhance an object, like a nebula or a galaxy. Because if you go too much, I mean, it looks like some plumage of a bird, you know, I don't know. Hang on, I have to find it here. Does anyone, oh, there it is. Like anyone can tell me, you can't hear. So that gives you a better indication of, can you see some of the detail here in H alpha?
Yep.
Right. So that really shows that the addition of H alpha here certainly helped with M82.
Now, did you blend that through pixel math, or did you blend that through?
Well, so Truth in Advertising, this example was done before I was even working with PixInsight. So I had different ways. This would have been the old way in Photoshop, right? But in PixInsight, I'm trying to think of an example that I might have blended. I might have done M33 that way. I have to go look at M33. But no, I would have done it differently there compared to what I would do now in PixInsight. Like I said, in PixInsight today, the blending method, secret sauce. Might be secret sauce. I will tell you that I'm actually using one of the blending modes of Photoshop to blend those pixels together.
Gotcha.
That's the secret. So that blend script that I showed you is what I'm using to help me blend things together. I could use pixel math, and I would be using pixel math, but the expression I want is in that blend script.
Gotcha.
Yep.
All right.
That's where it is.
There you go. There you go. Secret sauce.
That is the secret sauce. Let's see. So M33, I actually don't think I used H alpha. Let me look. Oh, no, I did. Yeah, I did. Okay. So this is one that I did. I think I was just starting to use PixInsight here.
Okay.
So you can see how long ago it was, right?
Wow.
But if you look at, now check this out. I think I have it here. This is just H alpha.
Huh.
This is just H alpha of the galaxy. Isn't that insane?
That's crazy.
Wow.
Yeah. So here's a 604, right? And then all of these, look at this. There's like little supernova explosions and, you know, H2 regions and whatever.
That's amazing.
Longan spheres. Yeah.
Unbelievable.
Yeah.
The detail's amazing.
And this, of course, you can do because, again, it's so close to us.
Yeah.
But if you're doing something like, I mean, I don't know, M66,
yeah,
I don't know, that's at the edge there, right? You know, 30 million, 40 million light years away. Once you get out to 60 million and beyond, yeah, I don't know that it's going to really be a big help. You can argue about it. I do know, for example, someone spent time on, what is the one, 12, it's not 1283, 12, I can't remember now, 1250 something, the one in the Perseus cluster. 12 something, 1250 something.
I don't remember
that one. People have tried to use H alpha, and that one's pretty far. And I know they're out of the band on it, but people somehow get away with doing it. 12. Let me do.
It's Fornax.
12. There's only one of them.
Yeah.
Oh, I don't have it in my list. Yeah, I don't have it here. Nope. That's an old image that I have somewhere of it, but I don't have it in my list here. Anyway, someone can correct me online.
That's all right.
12 something. NGC 12 something.
Is it 12? Is it 1275?
Could be.
Yeah. I'm curious.
1275. It's in Perseus.
That's it.
Yeah.
That's it. Yeah. See, people have tried to get those H alpha filaments. I know Jay Gabani, for example, he has a nice image which does that.
Oh yeah. Yeah.
Steve Flanagan said he really needs to get that filter that you can expose the moon and Andromeda at the same time.
Oh. Nice filter. That's not a filter, but everyone does understand what that picture was, right? That was just a composite.
Yeah,
it's a composite.
Yeah.
You will not get that picture.
That's all that is. That's to show the field of view. That's right.
Mark said, thank you. I'll have to remember that when I try with H alpha. Andy wants to know which external repositories, if any, do you use?
External repositories. Oh, so Harmit Bornemann is, I believe, his name, and Herbert, his friend, helps maintain that repository. So I guess I can just go here and show it, right?
Yeah.
Yeah, it's Sky Pixels or something. Let's see. If you go to resources and you go to, where is it here? Maybe community?
Or
is it updates?
Updates.
It's updates, I think.
Oh, updates? Where's
yeah, right. Go down.
Down.
Right in the middle. There you go.
Good.
There you go.
There it is. Yeah, that one. Sky Pixels.
Okay.
Yep.
Okay.
Yep. Yeah, HVB, I think, is Harmit something Bornemann. Well, it could be Hugh something, but his name really is Harmit.
Okay.
Yeah.
Okay.
And Herbert, is it Walters? I think is the friend that they together do that. And I'm sorry if I've messed up his
No,
name.
that's okay. I guess I got a question for you. Super bias.
Yeah.
Yeah.
I know there's supposed to be, fantastic, but I haven't done it. I haven't seen a big difference.
Yeah.
Yeah. I just go ahead and make. I've been making masters out of 50 biases.
Okay.
They're so easy to take.
Sure.
And I do take them occasionally, through time, to just be sure that nothing is changing with the camera.
Yeah, I just did mine today, actually.
And so I did, for a while, I was using super biases, but I just didn't notice that there was anything. I didn't notice an improvement. So with the data that I was using, I couldn't tell.
Now, do you use a lot of the batch processing scripts yourself, or do you go more manual?
That's a really good one to consider. When I got two computers here. When I use the batch pre-processing, or now there's the new one, weighted batch.
Yeah, the weighted, yeah.
Right. But just, for either one of these things, I only calibrate. See the little checkbox there?
Mm-hmm.
That's the important thing. For me, I'd prefer just to calibrate the data and then take it through the next steps, going through, it might be star alignment, and then, I might do mirror denoise, and then I'm going to do image integration, then mirror denoise or whatever. But I will step through and do that, because if there is a problem, I don't have to worry about where in this process there was the problem, because it just yells at me, gives me some funky answer. And if you're familiar enough with, those answers, you can say, oh, that was in star alignment. But what you'll often see is in the forums, people will say, I use batch pre-processing. It gave me this error. Why isn't batch pre-processing working? It's not batch pre-processing. It's the process that it was working with at the time. So it's great if it can work automated, but I would highly recommend people just calibrate the data first and just use those processes so you can see how they fail, because they will, not that they fail, but there will be, kinds of data that you'll use where you might need to adjust a parameter to make it work. Okay. And then you'll know that the parameters that might, the script might take advantage of, or that you might have set up in the script, may not flow through when it gets to that point. So calibrate only to begin with, I think, is a really powerful idea.
Yeah, actually, I just started doing that after watching your video, because I did everything at once. I said I just threw everything in there, and it causes more harm than good most of the time.
So here's the thing. You can earn the right to use automated routines only after you've done things somewhat manually.
I like that.
And unfortunately, there's an expectation that automation means that it's going to somehow have default parameters,
right?
Default things that are going to, in general, work. It just doesn't really work out that way. There's just too much variation in data and in parameter space and so on, that it's really an understanding of what the automation is doing for you. Mm-hmm. So, if you're going outside splitting wood, right, and then you make a machine that's going to split the wood for you, you're going to need to know how to split the firewood to begin with, in order for that to know that the machine is going to be able to do its job. You can't go out there, just stick the machine out there and say, go, and expect to have nicely cut firewood that you're going to bring in the home, in the house. Right? I mean, maybe you can fiddle with it and, something, but until you've cut the wood yourself and you learn, okay, I've got to hit the axe just here, and then, I've got to kick it away. I don't know how people do it.
I'm making stuff up.
No, but you make a really great point. You make a really great point as far as
I think you got to earn it.
Yeah, you got to earn it. Learning and understanding each of the steps.
Yeah.
And going that route.
You got to get the little badge. The badge says, I can use fully automated scripts now.
I like it. Yeah.
We're gonna have that. It's gonna be our first pin.
Yeah.
But yeah, no, I agree with you 100%. I mean, I was more like the one that just dumped everything in there, expected it to come out right, and it never comes out right. or rarely it comes out right.
But there's another subtlety though. It's not that it never comes out right. Sometimes things will come out, but then again, as a beginner, you don't often necessarily know that what came out is the best it could be.
Yeah,
right?
True.
So sure, something came out, but is it right? Or is it really, correct? There was someone that recently posted on the forum and they had, green lines coming down their image and people were making fun because it looked like the Matrix dripping down. But the person who was posting was, was saying that, here's the data that I've got after I ran it through my automation, right? And now he's just trying to correct for this thing. But the problem isn't correcting the green thing. It was something way back, much, much earlier was a problem. It isn't that the output now you're going to somehow do something because the output is correct or the best it could be. No, the problem was much earlier in the stage. And taking care of that earlier is really what's more important than trying to compensate for something that you think might be right at the end of the output of some automated script.
Yeah, absolutely. You can put a lot more time into it trying to fix something that ain't broke.
Yeah. Or not knowing something's broke and trying
to, exactly. A lot of times you're right. This if you're using the automated, especially in the weighted batch processing, there are so many things that you could really touch in there and mess something up really bad. And then when it comes out, to your point, it came, garbage in, garbage out. So you got to be very, very careful if you mess around with those settings. Making sure that you know what you're doing exactly is very important.
Yeah. Especially, especially like I say, especially for me who just getting started. I tried those the batch processing, post processing, and things like that. And and Adam, you're exactly right. You don't know what for someone who's new to the software, you don't know what you're really gonna get. You don't know if this is right or not. Yeah. So going through the steps and, like you say, earning your stripes. In a way of going through each of the parts in each of the phases of integration, each part of integration in the process. I think that's where you really are going to appreciate it.
But it also reflects a philosophy, and I mentioned this earlier. It is to incrementally do things. So automation is really a very big step. It's one big chunk of many things that have already gone in there, right? But processing, when you make adjustments to an image, you generally want to be incremental about them. And so if you have to commit yourself to any one big thing, it can be significant. And instead, when you do lots and lots of small changes that are correct along the way or that are doing things well along the way, you tend to end in a place that is much, much better. And so this idea of automation versus doing things manually is like that. It's not so much that the manual part is necessarily, it's a learning process, but it also tends to be incremental because then you're only doing a smaller fraction of the work at any one time. And it makes it easier to see the quality of the output and understand what's going on rather than look at the convolution of many things that you've done to the data.
Now,
go ahead.
No, I was going to ask you, now, also, one of the things I was also kind of curious about with your, with everything you're doing, what is your, like right now, what are you focused on as far as, like your personal like targets, or what are you doing? Do you usually how do you choose what you want to do for, a given night or a given series of nights or things like that?
For me right now, my choices are less than they used to be. So I have time when it's available, using the system that's doing the research on top of Mount Lemon. And then I otherwise beg for time. That's it. So right now, I beg. And some people have been extremely supportive of me and have given me some time to collect some data, and you'll find them whenever I post these images. I always obviously credit people who, or organizations or whatever that have been very, very kind to me. So right now it's a combination of the kindness of strangers plus, or not strangers, friends and strangers, I guess, plus some time I can sneak in on the instrument that I'm working with on Mount.
Sure.
So I take what I can get. That's really the answer. It's not.
Okay.
I'm not as freewheeling as I could used to be. My parameter space has shrunk a little, but that's okay. I'm still keeping busy.
There you go.
And one thing I want to mention is that on my site you'll see that, in case people are unfamiliar with my style or the kind of information that I try to get out there, there are free videos that are located at my website here. You'll find them. You can find examples where I was, as you mentioned earlier, I was on the Astro Imaging channel.
Yep.
But there's other videos. There's one that people like a lot, which is information about the dynamic background extraction, because I approach both its explanation and its use in a way that is different than is normally seen and done. And I also have, and I still have to get there by Google because I don't know how else to get there, but you can also find me on YouTube, among other things.
Yeah.
And on YouTube, you can see that I also make videos and things available for people to see. But obviously they're full-fledged videos, but I don't publish everything. I want people to become members of my site so they can get into the full collection of all of that information. But you can find ongoing bits of flows of information coming out from me in various forms and formats.
So if you're a person like myself who is really new into PixInsight, who just picked up the software, really learning about it, and trying to get over that, a lot of us call that learning curve.
Yeah.
I highly recommend, checking out Adam's website and, and even taking a chance on, on looking at those free videos. But I would say I would highly recommend, because Dan, you're a member of his website and getting those videos. And I'm actually, being that new guy, trying to get into PixInsight, I'm actually going to go ahead and I'm going to invest into that and
again,
do that myself.
like we were talking the other night when Adam was in the chat. I gotta tell you, it's definitely worth the investment, and I learned something right out of the box. So I mean, the first couple of videos I started learning stuff. So and I thought, I knew everything about the screen transfer function, and sure enough, I was incorrect. And I found some other stuff in there that you would be like, oh wow, I didn't know it did that. And there's a lot of things like that throughout the entire fundamentals part of the video. And I'm once I'm done with that, I'll get the horizons. I'll get the horizons. I mean, definitely an impressive set of videos, I gotta say.
Well, let me just show you something that I think is an idea, an approach to not only teaching, but to investigate how things work. Because when you have a program that's like this and it doesn't tell you what it does, you have to discover it. And there are tools at your disposal. I mean, the program can't be, so understandable. You can't figure it out. There are ways, of course, to figure out what it's doing. And just as an example, if I open some random image here, I don't know, there, I'm opening a random image. And then I'll get Pixel Math out. One of the coolest ways, and of course, if you've watched my stuff, you will know this. One of the coolest ways to learn how one of these processes interacts with data, certain kinds of processes, is you can create a gradient, right? So in Pixel Math, you create a gradient like this. This is the normalized position of a pixel in the horizontal direction. That's what this is. So imagine in the X direction here, you go from 0 to 1.
Okay.
So what this is going to do is it's going to output values, actual values from 0 to 1 as you go across horizontally. And it'll do that for every single row here. So the first number it puts here, it'll be 0. And the second number, it's going to put 0.0000 something 1 until it goes all the way over here and gets to 1. So it's going to start with black and then it'll go all the way to white. So this will create a gradient like that. And this gradient then, now if I go do something, if I go do an operation like I use curves or histogram transformation, or I use a, what's it called? Local, I can't remember the name. What is it called? Local something, something. Local histogram something. What is it called?
Local histogram equalization.
Yeah, that one. You know, what is this thing doing, right? Well, what you can do is you can take, you know, a grayscale image like this, and you can apply it to, you can apply the process to the image, and then by seeing what it does to the image, you can then see what it's doing to the dark things or the bright things, because this image represents all possible brightness levels, right? And so when you interact with the gradient, you're actually seeing what's going to happen to all of the brightnesses. Now, maybe this example wasn't the best example to use, but yeah, it's doing something, but not very much. Do you see what it's doing over there to the blacks?
Yep.
Yeah.
Yeah. So, you know, it's obviously raising the contrast. It's making things that are a bit mid-tone and brighter, a little brighter, and things that are dark, a little darker there. But that's the way that I try to demonstrate how things work in PixInsight. It's by finding ways to illustrate behaviors or to demonstrate patterns. And I think that that's a very powerful way of showing how things work, because you gain an understanding. And then with that understanding, you can begin to see, you know, what some of these parameters are. If you look in, I think the one that I do is exponential notation. I believe this is one of the free ones, I think. But I mean, if you look at, if you were just to walk into PixInsight's universe and you look at that function, it says power of inverted pixels. Now, so then the next thing you do is you come over here to browse the documentation. You go, okay, it's got to mean something. And of course, you don't see anything there, right? So now you're stuck. What in the world could that possibly be? You can look in a book, you can look online, you can look anywhere you'd like. You're probably not going to find what power of inverted pixels means, right?
Right.
Probably not. So what are you going to do? Well, you can do like what I described, which is you can look at the difference between an image before and after, and you can actually say something about how it works. And then you can begin to understand, you know, what this does and how it works. This one, by the way, is something you can look for online because it's based on an older idea, screen mask and invert. But these functions, you know, have behaviors, and you can discover what those behaviors are. And then once you do, some of these things might make sense, like smoothing or order or whatever the parameter names are. They'll make sense. It makes it easier to understand what a tool does once you dive into its behavior, once you understand some of these things.
Gotcha.
So those are the connections that I try to make when explaining how the software works. It also means, though, that if you look at, again, those sections and you look at, you know, the times that I might spend, let's just look at a screen transfer function. I spent half an hour
I know,
explaining the screen transfer function, right? But I felt it was necessary because I get to show you all of the different kind of dimensions of the different ways that you'll interact with it, and why, you know, certain things are the way they are.
Yeah.
Now, another one that I was noticing is that you also, not just in addition to fundamentals and horizons, if anyone is interested, they can also arrange a little bit of time with you. Is that correct?
Yeah, so right. You can see here that
the office hours.
Yeah,
your office hours.
Office hours. Yeah.
Love it. Awesome.
This is something new for me. I haven't had that many people take me up on it yet, but it is an opportunity if you just really get stuck. And if it's an easy question, you know, I can just jump on with you. If it's something that I can answer in 2 minutes, I'm just gonna feel happy that you found me and you might consider becoming a member.
Sure.
But you know, if you want to work with me a little longer, we can work on something together. I can solve a problem. I'm kind of it doesn't mean I'll know the answer, but if I do, then I can become like a convenience thing. Instead of struggling to figure out what in the world, is going on, it might be something I've seen before. I've seen a lot of stuff.
Sure,
So
sure, yeah.
The set of things that I have seen is large enough that there is a good probability. It doesn't mean that it's all things, but there's a good probability that it could be something that I could be helpful with.
Gotcha.
Yeah.
Awesome.
So that I become a kind of a concierge of astrophotography.
That's awesome.
That's awesome. That's really cool. Almost kind of, yeah. I was gonna actually use, I'm a Star Wars, and I was hoping to say you're more like a Yoda, but
no. So how I'd really like to be like, though. I tell you, now this is getting more kind of out there.
That's okay.
It's okay.
You'll notice that here I have things that I call the cosmic canvas. So you guys are probably old enough. You know who Bob Ross is?
Absolutely.
Nice,
all right,
everyone knows
Bob
little
Ross.
pretty tree in the corner.
Just in case people do not know who Bob Ross is, it's this guy.
Oh yeah,
I miss that guy.
Right? He had a
Oh,
TV
yeah.
show where he would paint and demonstrate different techniques in painting to make very beautiful pictures, right?
Yep.
And so that's what I want to be of the astrophotography world. I want to be kind of like the Bob Ross guy.
There you
That's
go.
what I'm doing that's what I'm doing in these tutorials, where I demonstrate, especially in these particular examples where you get the data, so just like you have the paint, you've got the brush, the same thing that Bob Ross has. And then we do it basically together. We make happy galaxies, and mistakes are okay, and all of that kind of stuff, right?
Oh, that's not a mistake. He was meant to be there.
Yeah.
Great guy. I think it was Saturday mornings, I think, if I remember right.
No stress.
Yeah.
Right after HJ Puffin stuff.
Yeah. I remember, he was also on PBS or something like that, wasn't he?
Yes,
Yeah, there he is.
Yeah.
There you go.
But no, this is awesome. Now with the with Canvas, is that something that is part of when you signed up for Horizons? Or
yeah. So right now I'm folding those. I call these are the full sessions of me processing data sets, and as I get more data, I'll just keep building more of these examples. The other way to think about these examples is that, processing a galaxy is a little different than processing a nebula. You do different things.
Sure.
Often people ask me, how do you know what to do next? Everyone knows what to do just to get the fundamental calibrations and everything. But then often in workshops, people say, well, how do you know what to do next? Well, oftentimes what I do is I take a step back, and I often have a vision in my mind based on the data that I have in front of me, what I wish the result could be. So I literally have a vision in my mind. And that this is like the Ansel Adams technique, right? So you pre-envision, or whatever the word, pre-vision, what you want that to look like, and then you try to work in that direction based on the tools that are available, say in PixInsight. You work in that direction. So that's what drives me to make particular choices or decisions, and those choices and decisions are different depending upon the object that I might be working on. Yeah, I made very different decisions and choices when I worked on, that's not actually a picture of it, but when I worked on this nebula and then I worked on this galaxy.
Sure.
I used the fuzzy hyperbolization, whatever script on this one, fuzzy logic thing, which is really cool. That's an interesting one. This one, of course, I didn't do that at all. It's completely different. Yeah. And this one is, that's an image that came to me, someone submitted to me, which is often nice if people give me data and it's relevant. This was taken from like Detroit, right? So it was, people often sometimes are somewhat critical that all my data is so good. Well, no, it's not all good. But here's example data where it really, was taken from the middle of a very bright city.
Yes.
Sure.
And still you can do really cool stuff. So yeah, there it is. That's what it looks like if I were to do that.
That's cool.
Yeah, that is really, really cool. Now you were saying that you when you get when you have an opportunity to image, it's usually working with the equipment that you're currently being used, like when you're working and stuff like that.
Right.
Is that also? Do you also have an opportunity? Is that also those remote sites or those hosted sites? Because I see, is that along the lines of what we're talking about? Is when you can go like to Chile or Spain and stuff like that?
Telescope Live is one of the places that recently I've been trying to get some data from them. So this is there. I'm just an advertiser. So this is Telescope Live site, and you can purchase credits and time on their system. It's in Chile. Oh, they have some in Australia, and they're expanding, I guess. They have some in Spain. Yeah. So there's different ways to access their particular network of robotic telescopes.
Yeah, and I guess is a really cool way to actually get a chance to, like, you're in Chile, to take something from like on the southern hemisphere, something like that. So it's pretty cool.
And for me, sometimes people have this. There's this visceralness to being at a telescope and acquiring the data yourself. And I've done that a lot. So for me, getting data kind of sent to me is okay at this point. And I think I've just it's not that I'm tired of it. I enjoy being at a telescope and collecting the data, but as long as the equipment is doing its job and everything, it just kind of does its thing. And then you get the data, and then once you get the data, it's the challenge really is to work with that data to produce or render something that is compelling in some way. So for me, getting that remote, using a remote system and getting the data is still very rewarding for me.
Sure. Yeah. Have you ever had a chance to do what I saw it in Astronomy magazine, a Messier marathon?
Oh yes, visually.
Visual.
I haven't done actually. I've never done an imagery version of that, but visually.
That'd be tough to do. You're gonna be up all night doing that. Messier marathon. I've done one. Yeah. The most I got was 82. That's the most I've gotten.
Oh, see, in college, you don't sleep, you stay up. So I did the whole 100 and whatever.
100, yeah. It's like 110 or something.
There's a nice 3-hour wait period, kind of, where you got to wait for the other things to pop up.
Yep.
Yeah. And then in the very morning, I never made it up to that.
And then in the morning, you got to get like the Andromeda Galaxy and a couple of things as they just come back around. And
Yep. That's too much. I can't. not in the middle of March in New York. It's too cold.
There you go. There you go.
If I was in Florida, maybe be a different story.
And I think I can't remember. I think there was something at the end of the night. It wasn't M30. It was it's so long ago. There was something that was just so almost impossible to see, but you could see it and cross it off. I know M74 is over there.
Yeah.
And then, the Andromeda Galaxy and all that. There was one other item, though. I can't remember what it was, but it was just always right at the end, and it was really hard to see. But I think I got it. So.
Yeah. Nice. Yeah, maybe I'll have a chance to do something like that.
It's a lot of fun. You should. I mean,
it's a lot of fun.
What it really does. I mean, assuming you're not using at the time, there were no go-to telescopes when I was doing it. So, you would star hop and you would make in advance basically your plans. So you would look at Uranometer 2.0, whatever it is that you get these books, and you have all the star charts, and you either take the book itself, or what I did is I actually transposed those stars, just the major ones, and the star hopping patterns on pieces of paper. And then when I was at the telescope, I would refer to the paper so I knew how to get there relatively easily.
Okay.
Yeah, and I was all crazy about it.
Awesome.
My friend actually did a Messier marathon with a 14-inch. We have a dome over out on Long Island with a 14-inch Celestron in it, but the dome was not automated.
Oh no.
So this guy, and he's one of the people that come on the show a lot. He sat there for like whatever it was, 9 hours, and he would slew the telescope, because the telescope would slew, and he would take the dome, and all of a sudden you would hear All night the dome. He came in the next day, and his arms were just like totally destroyed because of the amount. He couldn't lift his hands up because it was just so painful.
Oh my gosh, I can't imagine that.
And he said, and here we have a happy little gradient.
Yeah, that's it. Yeah, Bob Ross.
Jane, does post-processing decrease the true scientific value of the original image?
Well, so I think the answer is yes, because you're just not making a measurement.
Right.
If you're making a measurement, the only thing that decreases its scientific value is anything that would affect that measurement. So if you're trying to measure the quantity of the light, just literally the amount of light that you've detected, or the particular color of the light, or whatever it might be, anything that would affect that measurement is it. And sure, these things that we do with the data, if you're going to make a measurement, a quantitative measurement, then absolutely, you're not making a measurement from any of these images.
Yeah.
Now that doesn't mean this isn't a very technical and at the same time artistic enterprise, but it is not a measuring enterprise. Absolutely. There are things you can detect. I mean, just because it isn't a measurement directly, you can, detect things. There are people that discover supernova explosions in other galaxies. I found a supernova, a supernova exploded in a galaxy. It was totally by chance. You want to see it?
Yeah.
Sure.
Let's see. I got to share again. Sharing. Yeah.
What are you drinking?
I'm just having water, dude. Nothing harder than water right now.
So I wonder if I got to remember the name of this. 62 something. Oh, that's at the bottom. Let me scroll 1 second. I got a couple of galaxies. There's a whole universe here.
Oh yeah.
Yeah, you know what? I think that I did this before I made this site. So I need to come over here. I need to come to, not there. I made it go away. That's the problem. Kylum. There. Here, and galaxies. Now.
Wow.
It's down here somewhere, but I'm going to need to type it in because I know I'm going to miss it when I scroll by. So it's Control F NGC. I know it's 6240. That's the one. There it is. So, this is the image, right? But do you see the supernova? Of course. How could you know?
Yeah,
exactly.
I'm looking.
Yeah, I see it's right there.
Yeah, that's right. Yeah.
So one of these things is not in. If you look at an old picture, is not in an old picture. So I think that I have below here. I'm pretty sure I didn't put it on this page. So I have to think. Where did I put that stuff? Oh, I know. NGC 6240, Adam Block, probably UA News. There we go. Let's see if they still have the page. They do. And here's the image. So I was able to look at now there isn't normally a nice arrow pointing it out.
Right.
But you can see in the SDS, the digitized sky survey image, it's not there.
Yeah.
But it is in mine. And that one's not a very striking one, I should say, right? I mean, it doesn't jump out at you, but for whatever reason, this was a galaxy that, again, there really aren't that many amateurs that have spent a lot of time on it. Mm-hmm. So I was looking at some other images, and there were two other images to look at. The Hubble has taken a picture of this thing in some data, and they later made a nice picture of it, but not at the time that I did this. And then there's this image. There's this, the digitized sky survey image. And in both cases, I didn't see I just didn't see that star. I'm like, I just happened to notice, hey, I've got like a star there. What the heck?
Wow.
I wasn't searching for a supernova, but sure enough, I went through the process with some help. I submitted to the right way. And then some astronomers took spectra of it, and sure enough, this was this is a type, was it 1? So this is I can't remember if it's straight or not. Type 1 is the a single star blowing up, not the not with a white dwarf, I think.
Okay.
Am I right about that? I can't remember. I could be completely backwards.
Right.
This is like this is the Crab Nebula type, is what this is.
Gotcha.
Yeah, which is not a very good standard candle, but it is a supernova. So
that's all. Wow. That's great.
Yeah. So, but the point is, that wasn't a measurement. I mean, I didn't really measure anything, but there are certain observations that you can make when you do this exercise of astrophotography. I also discovered, this one I probably do have here, a star stream around a galaxy. So when you take some deep pictures, sometimes you'll see things. Okay, now I got to type this one. Control F. Let's do NGC. Is it 3416? No, it's 34 something. 34. Uh-oh. It's not 34. I don't know what the number is. Let me go back to here.
Sometimes this is a good, problem to have, because you have some amazing images that you can go through, Sometimes this isn't a bad thing.
Let's see where. Oh, it's not 34. Yeah, I don't know. Oh, it's this one, 3614. I got the 6 and the 4 back.
Little dyslexic. That's all right.
That's all right.
So I don't know if this shows up, but there is a very faint thing there. Yeah, it's a star stream. It's one of these, sometimes there'll be big loops around stuff and whatever. But this is one that's associated, probably, if you look closely, there's another one.
Yeah, I was looking at
here. So this galaxy probably came in or went out, or whatever the orbit is, it got stretched. Its stars have been in a tidal stream now, and you can see the remnants of it, which tells astronomers something about the kinematics of the environment of galaxies and small galaxies and large galaxies and how they interact and so on and so forth.
Wow.
Again, telling the story.
There you go.
Yeah, well, these are exceptional. I mean, this doesn't happen very often, right? But it does, it can, and it's not a measurement, but if one of the cool things is that if you just pay attention, sometimes there are interesting things to be seen.
Absolutely, absolutely.
That's unbelievable.
Any other questions so far?
Simon Lewis got online from New Zealand. He's an astrophotographer.
Yes, he is. Yeah. He's a member. I know.
Oh, is he? Is he?
Yeah. He's a member. Yep.
Yes.
Very good.
Let's see. Mark said, "Stop taking your sippy cup."
Wow, Jane, that's a great shot of him.
Yeah, look at that.
Well, this, what makes this image kind of interesting is this is utilizing a very particular technique of DBE, and I can show this to you in this form. I won't go through the processing of it. It's not hard, but I don't have it set up, so this will be easier, I think. I'm going to try to show a full screen here. I hope it doesn't break the internet if I do that. So from current slide, yes. It might be hard to tell, but do you see how there's extra, it looks a little darker here in the middle. Yes. And it's brighter out here, right?
Down there, yeah.
So this image, this data is flat fielded relatively well, actually. The flat fields on this night of, say, some other data, they work fine. So I know it's not a flatting issue, right? Because if it worked on one little piece of sky and then I come over here, it's not working here. This has something else. And I think what it is that there are so many bright stars in this frame, the Pleiades, that it's a combination probably of there's a corrector flattener, field flattener, another optical piece in there with, maybe there's either the adapter, or it could be the inside of the tube. There might be some anodized reflections of some sort, but scattered light. It is just getting scattered light, I think, around the frame, and it's just more enhanced near the edges. So that's the problem. And one of the cool things that you can do with DBE is, instead of what many people do, is you click a bazillion
Alexis.
samples in the image. What you can do instead is select just a few of them that characterize what's going on here because of its symmetry. So most of this effect that you're seeing here is circularly symmetric and radial, meaning that there's kind of a gradient in the circular sense from outside to inside. And so if you can characterize that gradient, then you'll be able to correct the image relatively well. And so what I've done here is I've just clicked on this. You'll notice that there was kind of a corridor here where there just isn't very much of the Pleiades nebulosity. So I didn't click on, what I could see as far as the nebulosity to make these samples. And I just made 3 of them here. And by making these 3, these circles, then you define them. You'll notice up here, I have it defined as an axial symmetry. Axial meaning like, circle basically, around the axis of that circle. So all of these points effectively take this value here. I'm saying that at every one of these points, we should have something very close to what we have right there. And at every one of these points, it's a little darker, should be about the same here, and so on. So we take out that gradient. And so that's what happens when you apply.
Yep.
See the difference between before and after, how
Yep.
it gets more even? That
Sure.
evenness is the compensation that we're looking for. And then if you still have things that were not symmetric that still need to be taken care of, you can put a couple more points here. Just with more ease. You don't need to kill the thing with points. You just, put some points in each of the quadrants. And it was mostly to take care of a little bit more in the corners here. And then doing that really gives you that final compensated effect, which allows you to see the contrast. This is the red data. I knew that if I could compensate these non-uniformities in the red data, it's going to look pretty good, because the nebulosity is not that bright in red. It's actually brighter in the blue, right?
Right.
So if I could get a flat enough field to show nebulosity here in the red and here, I know I've got to be in the right direction. And so that's what lended itself to this image. I could not have gotten this image by just splattering those samples everywhere and trying to use DBE. Instead, it was helpful to do 2 steps. The first one with the symmetries, and then do some more selected little samples. That to me is what made this image possible.
Now, just as far as sometimes you're not going to have those kind of radial issues with the lighting.
Right.
Now,
then you got to be samples. Yeah.
Yeah. So is there I guess, a number that you would say per quadrant that would be? No, right? It just
because you need a character.
Trial and error.
Yeah, no, you need to characterize the non-uniformities. If, for example, there are features that are relatively distinct and small spatially. In other words, you have somewhere on the right side, you have like a blob of lightness for some reason. You're going to need to characterize inside and outside that region lots of little samples to have DBE kind of do its thing. One of the things that I try to take advantage of here, if you look at my parameter, notice 2 things. Notice that I have a relatively high tolerance. I'm not down there near point whatever the default is. I'm up there at 5.
0.75.
Yeah, right.
Yeah.
I'm up there at 5. All right. So by doing that, I am trying my best not to include anything that I think is like real. I just want those samples to really be sky, right?
Right.
And then notice how I raise the smoothing factor. See, in most cases, I'm not interested in any of those compensating for small detail, let's say abrupt non-uniformities in my image. Most of my images don't have that. If they do, there should be some other problem. And then sure, you can attack it with DBE, but in general, that is not what you want to be doing. So if you have more large scale non-uniformities, having that higher smoothing factor prevents, I think, some of the issues that sometimes people have, where if you have a sample and it doesn't characterize the sky very well, or it's near some star, and then it over or undercorrects in that area, then you end up with this kind of mottled background because of the samples that you placed, right?
Okay.
Yeah.
Raising that smoothing factor a little bit helps offset the nature of that kind of imposed artificial non-uniformity. You don't want that.
Now, how did you come up, as far as, I guess probably a little bit of, just your experience doing, astrophotography, of coming up with, these parameters, not using the default, for example.
Well, but it's not that I come up with the parameters itself. I have an understanding, and this is what I try to communicate in the videos, is I have an understanding of what tolerance is doing. I literally have a feel. So if I feel like I want my sample to be more tolerant for some reason, my samples to have more tolerance of the background, or to be more permissive, I should say, then I'm going to raise it. I mean, I can make it 10. So there is no preferred number. I am using it as it's not a slider, right? But I'm using it as if it were a slider. I'm typing in a number as if I want more or less. There is no particular preferred number that I pick. The same thing is true for the smoothing factor, for the sample size. The circles I make circular, but it comes from an understanding of what these parameters actually mean.
Gotcha.
So for example, I'll give you another example. You'll notice here, do you see how this says fixed?
Yep.
Right? So normally what's happening is that when you click here, this is what's being calculated. Now, of course, this is not a color image, so there's only one calculation, but this is what's being calculated for that sample's brightness. But what if, my friend, we have these 3 samples, and my inner ring, no matter what I do, it just overcorrects a little bit. It makes it a little bit brighter. I just can't make it, I just can't pick a sample here that for some reason, it just makes it a little bit brighter, right?
Right, okay.
So I come over here and I go, well, I know what this thing means. What this means is I'm going to not take the calculated number. I'm going to press the button here that says fixed. And then I'm going to take what it calculated and I'm going to adjust it up or down. But that's what fixed means. Fixed means I'm going to make it not a calculated number, but instead I'm going to choose the number myself, because I know what needs to happen, even though it's not figuring it out. And that's how I know what to do. It's because I have an understanding of what this silly little button means. And that's what I'm trying to give people. I'm not necessarily trying to give people the numbers. There aren't any necessarily numbers. In some cases it might be related to the math, but in many cases there's no particular number. It's an understanding of what the thing is doing. And then you have this freedom to pick the numbers accordingly.
Right.
It's just like if this were Bob Ross, he might tell you a brush, and a technique, but he cannot tell you the amount of pressure, 0.25 PSI, right? It's just not possible.
Right.
It's going to be your own pressure and your own way of addressing the camp. I'm not a painter. What do I know? The way that you mix the paint, the colors, whatever it is, right?
Yeah.
So that's the philosophy that I try to do when I do this.
Very cool.
Yeah. I think one of the things that a lot of people make the biggest mistake of when they're using that, you think extraction, you think subtraction, and not, you know what I mean? A lot of people make that mistake, and that's another thing that I picked up from your video is I immediately thought, well, I'm extracting something, I want to take it out, so I'm gonna hit.
Yeah, no, this is more of a compensation, and you can compensate mathematically in 2 different ways, as you know here, for the correction type. My method is to use multiplicative, where it's like a kind of a flat-like action where you're multiplying or dividing to make the values compensate for whatever non-uniformities there are. There is a subtraction method, which obviously does add or subtract, but for the kind of data no, there's a whole thing. I'm not going to get into this right now. The kind of data that I'm doing, division is, I think it should be the default. I think it's the right answer in general. I don't know why people's default is subtraction. It doesn't make sense to me mathematically. So that's a whole argument that I'm willing to have with other people.
Sure.
Yeah, so division, I think, is the right answer. I'll tell you this, most non-uniformities that people see in their images, you're going to say, where is that coming from? Is it coming from a flat field that just didn't correct the image perfectly? Or is it coming from, sky aliens who are illuminating your chip? It's errors in a flat. And if you want to correct an error in a flat, you do it multiplicatively. Right. You do it with a division.
Okay.
Yep.
That's good to know.
Dan from Facebook says, thank you for all your time, Adam. You have an impressive skill set. I am now going to sell all of my equipment and take up knitting.
This is not the inspiration that's supposed to.
However, on the flip side of that coin, David from Facebook says, I literally just purchased your fundamentals. So before I start, what's the best red wine to pair with this for the first few sessions?
Oh my God.
Good question.
I would do something sweet, whatever it is. It needs to have a little
it's got to be a little sweet. No dry.
No
sweet. Get like a nice Pinot Noir or something, a little something like that. Don't get
a nice bouquet and
there you go, perfect. Get those fragrance in there.
There you
go. One question I had is with everything that's been happening right now. Are you planning on doing? Because I understand that there was or if they're going to do it, a NEAF, like a virtual NEAF, or next year. I'm sure do you frequent NEAF quite often, or NEAS?
I only went last year, and it was, so I've gone twice. Last year,
heard about your session last year.
And then 9 years prior to that, 10 years prior to that. But yeah, I went last year. It was great. I mean, it's a nice conference. I had an opportunity to speak and do a workshop. And of course, being in that part of the world at the time was nice then.
No, not now.
Then it was nice.
Yeah.
Because that is actually the area that we were hearing about initially, right?
Yes, it was.
Show?
Yes.
Yeah.
Well, it's a little bit further north, but it's in that area. Yeah. They obviously canceled NEAF, obviously, and and they rescheduled for, I think, September 12th, 13th, 14th, 15th, I think. Yeah. We'll see if that happens. But I mean, we'll see what happens. I've been going there every year for past 12 years, 10 years.
Now you have the right accent for it, but I should also mention that I'm also associated with the one on the other coast, which is AIC, the Advanced Imaging Conference.
Sure.
Okay.
And I should mention that as well. And now I'm going to share again because, I'm sorry, my cat is now playing with something. Can you hear that?
Yes.
Stop it. Hang on. I got cat problems. Sorry. Okay.
No problem. That's okay.
This I do want to share because it is relevant to everyone, not only PixInsight, but what are you doing?
Gotta love it.
Oh yeah.
She found an Allen.
An Allen key,
of
course.
Okay. So there is now, because of what is going on, this goes back to what you were saying, Eric.
Yes.
There's a site called the Advanced Imaging Conference. And this takes place now on a 2-year cadence, 2-year cycle. And, the big meetings and all of that, really spectacular speakers and everything. But the AIC has opened up their site and their library of all the recordings of people who have given talks.
Oh, nice.
Wow.
Including all the workshops. So these are the big luminaries of, astrophotography. It even includes the talks by invited speakers, very famous people, right? David Malin
Okay.
gave a talk, right? And other, other people that you would have heard of. So all you need to do is go to the site and create an account.
Okay.
It's free. Now, I am an administrator, so you don't.
Yoda at Jedi Council.
Yeah. I'm an administrator, but you create your own account. And then when you get there, you can go into the library.
Wow.
And then you can see people's presentations.
Wow.
Notably, in terms of those that are interested in PixInsight, you'll notice that I gave a talk for 90 minutes, twice in a row. Sorry. On PixInsight.
Sure.
You can see some of those explanations, some of which I've lightly touched on here, but there's more. So you can see not only those talks, but many other talks that are all relevant to astrophotography in general. Planetary stuff, everything.
Nice.
Carrie Ann here has the kind of the Twan type stuff.
Okay.
Yeah.
I see Warren Keller in there too. I see a bunch of people. Yeah.
No, this is
Andy Galasso.
And this is interesting as well. This is Dr. Zabuldoff, whose interest is in, well, her interest is varied, but in this one particular case, it's kind of a citizen science or very pro-am kind of science, where potentially you can hook up with her and as part of this group and try to detect the optical components of gravitational wave type events. I mean, that's cutting edge stuff, right?
Yeah.
Yeah.
wow.
And from that, you can be written in papers and make all kinds of cool discoveries, but basically use your telescope to do real science that is that would be no one's ever done before effectively. So
Wow.
That's something to look into. Listen to her talk, and she'll explain all about that.
It's very cool.
Yeah.
That's great stuff.
Yeah,
Man. It's good that they open up their stuff like that.
Yes,
Because,
yes.
Especially in the times that we're in right now, where everyone's talking about social distancing / whatever.
Right.
I mean, I think it's great that people are opening up things, even stuff like this, like Zoom and stuff like that. I mean, people are starting to opening up more things and realizing there are other ways to get information out there.
Yes.
So,
Exactly. I totally agree there.
You learn by necessity, I guess.
Yes.
So,
yes.
So.
I've got a lot of stuff to log into and join now. If you can read a lot of cool stuff.
Yeah, absolutely. More stuff to learn.
Absolutely. This is going to be some awesome stuff I can be doing over the next few days or weeks or whatever.
Yeah, I hear you. But wow, so we've been on almost 2.5 hours.
Wow.
Is that true?
That is true.
I talk a lot.
No.
It's been great. It's been great.
It's good. And we've been having people come on and off, up to about 50 people at one point, and now hanging steady at about 35 watching us. So
35?
Yeah. We'll probably have about 1,000 views by midnight.
Yeah.
Well, 2.5 hours sounds like a pretty good chunk, so I won't overstay my welcome. I appreciate you guys letting me come on and kind of chew the fat or whatever the word would be with you.
Yeah, well, you do have one last question, and we'll leave it at this.
Okay.
Dan from Facebook asked you has there been any reported improved sky conditions due to less flights and less pollution?
Interesting. I would assume that in some places that would be true. I haven't made that measurement. That would be an interesting measurement to make, though. For example, let me just give you an off thing. There are people that study earthshine, right? So you look at the reflected light off the moon that comes from the earth, reflected from the earth to the moon and then back.
Gotcha.
And that can give you a sense of the total cloud cover on the earth. Well, the total cloud cover on the earth is affected by the number of airplane flights in the sky. And so maybe earthshine looks less bright now than it was.
Maybe.
Hey, you never know.
Maybe.
Never know.
It's a good guess.
So anyway, I have no idea, but I think that would be that's a cool thing to study, and it would be an interesting thing to learn. I'm sure there are a lot of things that are of the like because people have changed in a very dramatic way the way that they're interacting with the world compared to what they were. I mean, people aren't driving as much, and people are, you know, sitting on their computers. I'm sure the internet or cables like burning up because of, I don't know. You know?
I need more bandwidth.
Yeah, that's what we're burning now. We're burning bandwidth versus fuel.
Yeah, exactly. I'd rather burn bandwidth than fossil fuels. So.
Yeah, electrons are cheap. They're everywhere.
Exactly.
Simon said he saw, I don't know if this is cloudy nights or Canadian people. I think it's Canadian people reporting that it had improved greatly on the eastern seaboard. Not much in New Zealand. It's already God's zone in New Zealand, so you don't know about it. Simon also says he watches your videos constantly. He always learns new things. It's so awesome. And I think that's the last comment right now.
All right.
Well,
I wish you guys a good night. And again, thank you very much for having me on. And
thank you for coming on.
No, thank you. Thank you. Really appreciate it.
Thank you for coming on. And I know that the viewers are getting a lot out of it. And remember, AdamBlockStudios.com. Go and check out the free videos. You like the free videos, become a member, and you'll have access to all the fundamentals and the horizons and whatever you need. So thank you so much, Adam. I appreciate you again coming on. Yes. And Eric, thank you for being the wingman today. My
pleasure, bud. My pleasure. I'm going to sign up for Adam's website right now. So I'm getting out of here.
Again, Adam, thank you so much, and have a good night. Get some rest and go on that jog.
Oh yeah, well maybe tomorrow.
Have a great one, guys. Thank you.
Have a good night.